Hey YouTube. So let's do a quick comparison between the Braman TBM 829 and the Fluke 117 digital multimeter. I've been asked a few times now about the Fluke 117 usability. Yes, they're perfectly usable for electronics repair, but I'm going to do a comparison with something which costs in the same range as the Fluke 117 from Braman or Hellman Titan in South Africa, and that is the TBM 829. Now, starting all the way from the beginning, the 829 has got a fantastic LCD display. Lots of information to be seen. You've got your analog bar graphs, you've got pretty much all the features and functionality of this meter over here, and of some bigger meters. It also allows some features such as DC voltage measurement with AC ripple measurement on top of it. It has the auto check function, which this one does too. Auto Z, pretty much the same functionality. Okay, so Fluke 117, we've got volts AC, volts DC, millivolts AC and DC, ohms, continuity, diode, capacitance, AC amps, frequency, DC amps, and then of course the volt alert. Now this one, pretty much the same functionality again. We have volts AC, volts DC, millivolts AC, millivolts DC, you've got your ohms, continuity, and this is conductivity. You got temperature 1, temperature 2, capacitor, diode, milliamps, amps, microamps. Pretty much more functionality than this one. Also, this meter is rated more accurately. What we're going to do is we're just going to throw a few DC voltages at the two meters and see how the two compare, just as a matter of interest, to see how well set up the meters are. So just getting my things in order over here. Let's start off doing some testing with the meters connected up in parallel for volts testing, and see what sort of figures we come up with. So we've got our two probes, for want of a better word. Well, they are both probes. And then we need to jump this onto here. Right, so we've got our two voltages set on our two meters. One's not contacting too properly, so let's just redo that. There we go. Okay. So both meters are currently connected to the voltage source. Let's just run it down. Okay, so we've got 1,242 volts. Fluke 1,241. Well within its spec. If we just up that a little bit, 1,245, 243. I'm going to crank that up to a little bit higher. 9.827, 9.82. Now this is a 6,000 count. This is, I believe, a 20,000 count. So, or 10,000 count, sorry, 10,000 count, 6,000 count. I think, I stand to correction, I could be wrong with that, but as you can see, the Braman does have a few distinct advantages when measuring voltages sort of below 10 volts. If you go down past 5 volts or 6 volts, then of course they're pretty much the same on par sort of thing. The only difference is this meter is also going to give you an indication of AC ripple on your DC voltage. Now, if we head on over, you can see you've got the bar graph. Same functionality on both meters. Both works quite nicely. Power supply is not necessarily the most stable when it comes to stepping down the voltage, but yeah, for all intents and purposes it's fine. We're going to go over to a fixed output regulator. So here we've got a fixed voltage 5 volt regulator. It gives 5,046 volts, 5,044 volts. So again, they're still pretty close. So I'm quite happy with the output there from the Fluke 117. I do notice that the battery warning indicator on this TBM 829 is on, which means I need to replace that battery pretty soon. I'll get that done. And yeah, as far as the functionality goes, quite nice. Both meters are quite usable. Both of them have got a fairly substantial backlight. which does get the job done, especially in a darker environment. So yeah, what else can we talk about between these two? We can talk about deltaing out values of leads and stuff for resistance measurements. We can talk about the min-max functionality on both the different meters. We could talk about the extra functionality that this meter has, which it does. It does have a lot more functionality than the Fluke 117, and for the money, you're going to get more out of it. Fluke 117 advantages: size. If you have a look at this meter, it's quite a small little meter, quite ergonomically designed. The Bremens are very large meters. I mean, technically you could get an idea of what I'm talking about just by doing that. It's quite a bit larger than the little Fluke, and width as well is quite substantially more meter when it comes to the Bremens. Now, I've got three Bremens, sorry, in a similar form factor. I love these meters, I won't change them for anything. But you'll find I use the Fluke 117 on the bench a little bit more because it's portable and I can move it around a little bit easier. So, at the end of the day, which one are you going to use? Just to sort out any sort of discrepancies. Both of them are using Fluke leads at the moment. I need to verify this one's battery quickly, but all in all, both great meters. Subsequently, did turn out to be a battery. We've got the new battery installed. I've got this meter on its very simplest form for volts measurements, volts DC, and in fact the same battery, we're going to check it out. So on the Bremen we have 7,009 volts. It's slowly growing, but under load it'll drop down pretty quickly. And on the Fluke, as you can see, we lose a digit there, but still, for all intents and purposes, great for doing general testing, etc. Let's check a diode so I can show you guys what I enjoy most about the Fluke as opposed to the Bremen. Even though I prefer the Bremen meter itself, I just want to show you why the Fluke has a little distinct advantage in my opinion. So let's take a look at that. Okay, so what I've done is I've brought a small selection of components across from my test bench over there, just for us to muck around with and do a few tests, etc., so we can actually see the functionality and measurement. Right, so first off we've got a little 1N4007, or sorry, 1N4007 diode. On the Bremen meter we go to our diode test mode. We can check the forward first, 0.5 to 0.7. As you can see, 0.529, but something you'll notice, silent. Nothing on reverse, back to forward, silent, 0.534 volts. Okay, now something I've always enjoyed about the Fluke, you go back to the same diode test mode. Reverse, obviously we'll have nothing, we'll have overload, so that stays the same. But on forward, have a listen. That distinctive little peep, just to let you know. Done. Very nice. I mean, it's absolutely minuscule, but for me it's something that I quite enjoy. Right, secondary. Let's have a look at something. Yeah, we've got a 10 microfarad electrolytic capacitor. So we're going to switch this guy to capacitor mode. Like I said, 10 microfarad. Guys, this isn't the way to test a capacitor, but it'll give us an indication of the microfarad rating of the capacitor. So let's check it out. There we have 9,27 microfarads on the Fluke. So let's try that on the Bremen. Remember, it's a 10 microfarad capacitor, so let's see how it does it. Bremen is a bit slower, but results more or less the same. 9.24 microfarad. Let's go back to the Fluke. 9.26 microfarad. Okay, so they're giving more or less the same reading. The only difference being that the Fluke seems to do it a little bit quicker. Now, what else can we measure here? Let's see. What do we have? We have a tip 41C NPN transistor. So again, we'd go back to our diode test mode on both the meters, and base to collector, base to emitter. Let's just see what we're getting over here. 0.6, 0.6, happy days. Reverse that, we should have 0, 0. Overload, overload, happy days. And then should have 0.6 here. So yeah, that is a very good transistor, NPN. So as you can see, we got our 0.6, 0.6. We should get the same results with the Bremen. 0.585, 0.588. Okay, more or less close, good enough. Gets the job done. Then we have a 10 ohm resistor. So we need to go up to our resistance ohm scale, and we're going to check what the 10 ohm measures at. Let's see. 10.1, right, on the Fluke. And let's head over to the Bremen and see what the Bremen gives us. 10.2, so pretty close. 0.1 of an ohm difference between them, or 100 milliohms. So yeah, that's not too bad. And we've got some more low ohm resistors. Let's check this guy over here. 0.1. Okay, on the Bremen, 0.2. Now, question. On the Fluke, we're showing 0.1 ohms resistance on the leads. Now, as far as I'm aware, there's no way of cancelling that out. However, on the Bremen, we can come in over here, short them out, delta. Okay, so when we measure, we're actually going to measure the 0.1. So yeah, that's quite nice. Let's see, what else? What else can we test with these meters? Well, nothing really here, I suppose. Your capacitors, your resistors, etc., all pretty much the same thing. Electronics is electronics after all. But yeah, for all intents and purposes, these meters basically do the same work. There's, like I said, a few advantages. Like this one will do your milliamps and microamps, bearing in mind this guy over here. If you go to AC amps and you change it across, you're going to be able to go down to 1 milliamp anyway. So milliamps. Difference being here is you can go down to 0.01 milliamps. Well, you can actually go lower in the microamp scale, but yeah, is it really necessary? Probably not. So yeah, for all intents and purposes, Fluke 117 compared to the TBM829 Bremen, both very good meters, just my opinion. While on the topic of multimeter discussions, I've put the 829 away. I've got here one of my more recent acquisitions, the TBM812, which is almost the same meter as the 829, but less functionality, but it does have the micro and the milliamps. And you've got your capacitor, diode, resistance, continuity, millivolts, microvolts, volts, AC, volts, DC. Same display, mind you. I do find the newer display a bit more crisp from the angle I'm looking at it at, and for that reason I think the newer meter, being this one over here, is quite nice. Again, the same sort of functionality, minus one or two little features. So yeah, quite a nice meter. How it would stack up against the Fluke 117 is pretty much the same. These two meters are almost identical except for the milli and the microamps. As far as technical spec goes, there's probably a difference in the accuracies and stuff like that, but both meters will do your work for your electronics repair business, no problem at all. This, subsequently TBM812, is actually in my portable electronics repair kit, It's used on location when I'm busy working on things. But I'm starting to feel that may be a bit wasted when the meter could be probably better served in the workshop. But we'll see how it works out. So guys and girls, if there's any other meters you'd like me to have a look at, compare any other meters that are in my collection, we can do that. I can put them up on the bench, test whatever you guys want me to test. Bearing in mind something else of interest, the Fluke 117 is Cat 3 600 volts, whereas the Bremen 812 is 1000 volts Cat 4. So this meter has a much higher safety rating. Subsequently, the TBM 829 is the same rating as this, much higher than the Fluke. The Fluke, however, is more than substantial for getting the work done, working on live circuits, etc. So for all intents and purposes, either of these two meters will do you a good job of measuring, testing, etc. If however you are an electrician and you don't need all the functionality of these things, then just go ahead and get yourself something else. I've done a review on this. This is the Volt Alert stick, or the Fluke T110 voltage tester. It does a fantastic job of just probing out the voltages, continuity, etc. Really a fairly decent piece of kit. I've used it substantially out in the field and I've had no problems with it. As you can see, mine's starting to wear out a little bit, but everything is still quite visible. And of course it has a really nice loud continuity tester, but the storage mechanism is also quite nice. So yeah, very, very nice little piece of kit. Hey YouTube, while we're on the meter roll, I thought let's do a review of something else which I've acquired. I did acquire it secondhand, but in relatively new condition. This meter was acquired purely for site work, more electrical than electronic. It is an electrician's meter, not an electronic technician's meter. So let's take a look at it. Yep, you're right. This is the Fluke 323 AC True RMS clamp meter. It's very watered down compared to the one that I used to have, but still a really nice piece of kit. So let's take a closer look at it. Now, the little Fluke 323, like I said, it's not quite the same as my old Fluke 336 DC-AC clamp meter that I ditched because I wasn't really using it. It is a smaller version, but more than sufficient for electrical work. Came with a nice little Fluke bag, etc. Like I said, bought it secondhand. Looks like it was owned by a vicar because they've subsequently engraved their name in over here. I purchased this through Cash Crusaders on the Bluff, which is quite nice, so I get the warranty with it and everything like that. But Vicar, I don't know why you sold it, but you shouldn't have. It's a very decent meter. Maybe you just found that there was something else out there that you decided to go for, but yeah, anyway, on to the topic. The meter is very good. I like how it works. We got a set of Fluke leads, not the most expensive or the best, but certainly adequate for general use. I'm just going to compare it slightly to the Fluke 117, as they are different category meters completely. I mean, the Fluke 117 is an electrician's meter, but it's got a lot more functionality than the Fluke 323. So the first thing we're going to have a look at is the buzzer. As you know, with the 117, you've got a nice latching buzzer on there, so yeah, that does the job quite nicely. This little guy over here, the resistance and the buzzer are both on the same scale. Again, it is a latching type buzzer, but the display update is a bit slower. Nothing wrong with it. Does a good job of it, so yeah, I'm quite happy with that. Now when it comes to doing measurements and stuff, the electrician's meter has to be pretty safe and you have to be confident measuring your mains voltages, etc. So I'm just putting some power on over here, and then we're going to take a look at some AC measurements. First one being that I don't think this is going to reach, because you're not going to get in there with those. But anyway, so let's just take a look at it with the the little clamp meter. We've got it set on the AC volt scale, connected up. We've got our 226.1 volts of AC, so yeah, that's quite substantial. That I'm quite happy with that reading, no problems there at all. As for DC voltages, let's do some comparisons on the bench power supply. So right now we've got about 3.9 odd volts, whatever it is, coming out from the power supply, so we're just going to read that. 3.988 volts of DC. We've got the little clamp meter in, so we've got 3.988 volts. So let's see what the clamp meter reads. 3.9 volts. Like I said, don't expect anything extremely accurate. These are very brute force instruments. They're basically designed just to be able to do a reference voltage check and move on. So let's have a look at the 12 volts. Right, here we've got 12,0 volts reading on the Fluke 323, and on the 117 on the same jacks we're going to read 12,02 volts. So again, accurate enough for doing reference voltage checks. You're not going to get millivolt accuracy out of the 323, but it's still a good meter. Like I say, the design of the 323 is more to get in, get your measurements, get out, carry on. The 117 is more of a general electronics, bit of electrical, well, it's general electrical with a bit of electronics on it. This is more purely electrical. The few advantages of this meter over here, of course, are the main reason for wanting to buy a clamp meter, your AC amps measurement using the clamp. Now, you don't need to use the leads for this. It's purely a function of the clamp section of the meter. And what this basically allows you to do is, let's say for example you needed to know how much current was flowing through this in AC amps. What you would in effect do is take your clamp meter, clamp it around the wire, and take a reading of how many amps AC is flowing through that piece of wire. Now, I think I've shown it before on DB boxes doing AC amp measurements, but if not, I think we shall have to do that this afternoon and do some AC clamp measurements to show you guys how it's done. I think that's a brilliant idea. Let's head on over to the 3-phase DB box and do a couple of measurements on there. So all in all, this little Fluke 323 AC clamp meter is quite a nice piece of kit. The one thing that I am not too happy about when compared to some of my other clamp meters with similar sort of safety ratings from Bremen is this is quite a hefty clamp. So getting it into small spaces is not always an easy task, whereas my little TBM 3030s have got tiny little clamps. In fact, let me grab the TBM 3030 and show you guys the physical size difference between these two meters. Here we've got the TBM 3030, which again actually does a bit more than this Fluke 323. This one will do volts AC, volts DC, amps AC, ohms, diode test, capacitor test, and all the other nonsense, whereas this one doesn't do a lot of that functionality. But again, the size. Let's have a look at that. Look at the clamp section alone. This one is so easy to get into small spaces and do your measurements, and the display is nice and readable. Both displays are about actually I find the Bremen a little bit better on camera, but actually in real life too, the Bremen does have a slightly better display. Like let's say for example we're going for AC amps. Here's your AC amps measurement. This one over here is going to give you 100 milliamps minimum. This one over here is going to give you 10 milliamps minimum. So a little bit more value in the TBM 3030 clamp meters in my opinion. But again, just my opinion, Fluke are brilliant meters. Different sort of markets I would suggest. Like for me personally, I use this one more on location than anything else. This meter is brilliant, it gets the job done quite nicely, but for those who are in HVAC, air conditioning, etc., the Fluke 323 is probably a good, more robust meter to go for. It's probably going to last you a bit longer, but again, we don't know. So yep, that's a brief first look at the Fluke 323 AC clamp meter, and a brief comparison between the Fluke 117 and the TBM 3030 against this little 323. So draw your own conclusions, ladies and gents. Buy the meter that works for you. Just as a bit of a price guide, these guys here sell at around 2,000 rands plus minus. These over here, the TBM 3030, can be had for around 600-700 rand, brand new. Fluke 117, different caliber of meter completely, so I shouldn't really be talking about it, but they go for about 3,000 rand. So yeah, there you go guys, the Fluke 323 AC clamp meter. Thanks for watching.